This is Mike Duffy. This is my ENGT 196 student project for the advanced workbenches. The first thing we're going to demonstrate in this project is the Prismatic Machining workbench. And we will start by doing facing operations on the lid of a box that we're going to make. And then we're going to skip it, but it does face the bottom side, and then we run a profiling operation to cut the shape that we want. And next we have our rough stock of our box. We're going to face that down. And then start cutting a pocket in the top. And a second pocket. And this will provide now the third pocket. That second pocket, you'll see a little ledge in there. That's going to provide the shelf for the tray that will be made out of sheet metal to sit on. Kind of like a toolbox tray. Now we're going to cut the outside profile. The lid is inset in the top of the box there. This is just cleaning up some of the edges, putting a little sharper edge in there in the corners. And we're going to etch a little lettering into the bottom. Put my name and the name of the class in there. You can see there's quite a few operations in this tool run by all the tool paths and check marks on the left there. Each one of those is a operation, like that number 6. Now we're drilling out the holes and with a peck drilling operation for the hinges, and then we will cut the outside radius on the top edge. Now we're going to demonstrate the kinematics. We put the box together, put some hinges on it, and then took the lid back off, or hit it. And we're demonstrating the tray, the sheet metal tray, lifting in and out on a distance motor on a kinematic joint. And the hinges working on a kinematic joint as well with an oscillating motor, opening and closing it. And then we showed the lid open, the tray pop out, and then the reverse. Close the lid. Now we're demonstrating the Knowledgeware. The box is linked together, so no matter if you change the length, width, height, the size of that outside radius, the box on the tray on the inside, the outer box, and the lid all change together accordingly. As you can see, it looks a little funky, but then we update the assembly and everything snaps into place where it should be as it updates, which I should be doing right about now. There we go. And I demonstrated again a couple more times just to show that it all works together and how it works together. Here we're going to change the outer radius a little bit. And the height. Now the width. then the length, and then I will update it again. And it will all come back together smaller. Now I demonstrate the kinematics one more time just because I like them and think they're neat. Now we're going to go ahead and take the lid from the box into the stress analysis workbench and try to break it. In this first test, I put a clamp on both edges of the lid and applied a force pushing directly up from the middle. As you can see on the different stress analysis, the different forces at work on it. This is the von Mises force scale. And here we have the reaction force vector and the compression and tension. And then next, I clamped one edge and put a twisting rotational force onto the other. And sort of broke the physics a little bit. I'm pretty sure we broke or at least permanently deformed the lid as well. That's solid metal, remember. And it's so much fun that I decided to also build a chair real quick and try to break it as well. And so that's what's coming up now. We have the displacement and the von Mises. And the reaction force vector, you can see them pushing up from the feet there where the clamps are. And this one, there's a force pushing directly down on the seat and also on the back as well. Thank you. If you enjoyed it and want to see more, please check out the longer video that shows some of the build.